Hey guys, welcome back to the RTO Tech channel. My name's Robert, and today we're going to be going over the couple softwares with the SDR-BRK. So let's first talk about what comes with the SDR-BRK itself when you order it. It comes with the unit itself, the SDR-BRK, two ZBM2 dual band antennas, along with a USB-A cable that has a threaded captive end for the unit side, and just a regular USB-A side for the laptop or EUD. This version of brick that I have is a TNC model, so the antennas are matched to that brick, so they are TNC as well. If you're wanting to do other options of antennas, those are up to you. Like I have this TNC Southwest antenna, Wi-Fi 2.4 to 2.5 and 4.4 to 5.9 gigahertz antenna, as well as this TNC 900 megahertz ZBM2 antenna that also pair up with the brick very well. So let's get started. I'm going to set the brick off over to the side after I plug it in. I'm just going to plug up the USB threaded connector, and then I will thread on the two included antennas that are TNC. Alright, now that the brick is all set up, I'm going to set that over to the side, and then we'll get the laptop out. I am running DragonOS, so if those who don't know about DragonOS, it is a operating system that is meant for radios and SDRs. Alright, now that we have the SDR-BRK plugged in and SDR++ running, we'll have to come down to our source menu and make sure we have our correct SDR selected. So for this, we'll be selecting the HackRF. And since this unit has two HackRFs in it, when you click the drop down, you'll notice that there are two serial numbers listed for each HackRF. And I made it simple so that you can tell what antenna port is what serial number. So you'll see that this 5F serial number is going to be this lower one. And I did that because not every time you're going to be running the same antenna on each port, and then it doesn't really matter. So sometimes you'll be running something like the 2.4 gigahertz antenna on one port, and then another antenna on another port. So it's really easy and convenient to know and distinguish which antenna port is what. So after we've selected the correct serial number HackRF, we'll come down, and there's some other things that you can adjust. You can adjust bandwidth, which goes all the way from 2 megahertz to 20 megahertz. Now with this unit, since this is using a single USB output and it is USB 2.0, if you were to run both of the HackRFs at the same time, you can only do 10 megahertz on each HackRF max, or 20 megahertz combined. But since we're just using a single one for this demonstration, we can do 20. Well, after that, what we'll do is we'll hit play, and you'll see that there's a jump in frequencies because we are in the FM band. And you'll see that I have the amp enabled, and then the gain is up. So we'll turn the amp off. We'll slowly increase the VGA gain. You'll also notice on the right-hand side of the software that there is a slider bar for min-max, and that is increasing and decreasing the noise floor and how much you are able to view of it. Over on the left side again, you'll see that there's an LNA, VGA, and amp enable. You'll want to increase those and adjust those based on your environment, but you don't want to adjust it to where it brings up the noise floor. The sweet spot is usually whenever it brings up the transmitted signal but not the noise floor anymore. So about right there, because you'll notice that the noise floor started to move with the signal that is being transmitted from the FM station. So now that we have the gain set on both tabs and amp is disabled that we chose, we can now listen to the frequency being transmitted that we are watching. Okay, another thing you can do is on the right hand side there's a zoom in and out bar, and wherever you have your frequency that you're listening to, wherever that line is at, and you zoom in, it will zoom in on that transmitted carrier. So we can zoom in right there and have a better signal analysis of what this is. So let me demonstrate what 2 tabs of SDR++ look like. So you'll notice that I have, just like how I demonstrated before, the 2 serial numbers right here. We're going to choose the CF antenna this time, and we're going to choose 10 megahertz. We're going to go ahead and hit play on the CF. So you'll see that in this second tab, this lower tab right here, which we'll use on the second HackRF inside the brick, it is automatically selected for CF, which is the HackRF that's already in use. So what we'll do is we'll collect this source, and then we'll go to 5F, which is the lower one, and we'll select the bandwidth to be 10 megahertz. And then we'll hit play, and you'll notice that you have 2 tabs of SDR++ running both HackRFs at a max of 20 megahertz total, and we'll go ahead and listen in.
Yelled at me.
You're happy about that?
Oh, indeed.
Well, you should raise
Okay.
jewels.
So where this really shines is that you'll be able to use 2 different HackRFs to monitor 2 different portions of the spectrum. So what we'll do is the 5F serial number HackRF will scroll over to NOAA weather while still listening over to the FM stations.
That guy's got 2 left feet. I may be wrong, but you...
Okay, there's the FM station. And then here is, let me set this.
It was partly sunny, with a temperature of 81 at Austin, 80 at San Antonio, and 84 at Houston. And again, at Abilene, skies were mostly sunny. The temperature was 79 degrees. Wind was south at 9 miles an hour.
Okay, so you can see that you can now monitor 2 different sides of the spectrum, 10 megahertz each, and gain better control or knowledge of what is going on in your area. Now, you don't have to do it top and bottom like this. You can simply just do it side by side, sorry, and run it the same way. It wouldn't be, let me make sure none of the other ones are running. And the benefit to doing side by side versus stacked horizontally is the fact that you can watch more of the waterfall. So you'll see that you can see more of the waterfall with the 2 tabs side by side, and that allows you to see more of the history of what is going on. So if there is a signal that is kind of weak or is not constantly transmitting like these FM bands are, or the NOAA weather station, it will show you the history of that, and you can kind of pay attention or see it, or you don't have to monitor it 24/7. You can occasionally glance at it and notice that, oh, there's this transmitted signal here. Let me scroll over, listen the next time that is transmitted. Okay, now that we've talked about the SDR++ software, let's go ahead and go over to the hackrf-spectrum-analyzer, which is on Linux and Windows. And we'll go ahead and run the tab. Now, it automatically starts you off in 2.4 gigahertz, and so what we'll do is we'll lower that down to roughly, we'll do 60 to 1 gigahertz. And we'll wait till it to start again. And you'll see that this is 61 megahertz, because that's what it's set at. I'll just do 60 for the simplicity of it. So it is 60 megahertz all the way on the left side, all the way to 1 gigahertz on the right. And what you'll notice is that this is the FM band, and then somewhere right here where my cursor is, that is NOAA weather station. In this 500 gigahertz, if I had to guess, that would be probably something related to TV. And then the 750, I'm not really sure, but that's the beauty of it, is it gives you a wide scope of the spectrum and what's going on around you, and lets you see whatever you would like in whatever frequency range. So this has the same thing as the SDR++. It lets you increase the gain. So for the FFT bins, that's something you want to adjust because that's your resolution for your scan. So the larger the scan, you can't really decrease it as much as like a smaller scan, but for this 900 something megahertz scan, we'll come down and we'll bring it down to 20,000. And you'll notice that on the right, the FFT has increased the resolution for the FM band. So now it's kind of easier to see and distinguish all those frequencies that are kind of packed in right beside each other. And we'll see what a high-end resolution looks like. So that's 5 million. Yep, see, that's the resolution of the FFT on a scan like this. So we'll bring it down to 50,000. And what we'll do is, so this antenna LNA is your amp. So if you click that, that will enable your amp. And then down here is antenna power output. If you have a bias T LNA or something of that sort that you want to power through the coax, you can click this check button to enable bias T through the HackRF. And then we'll go over to the chart options tab, and you'll see that the waterfall enable is checked, and then waterfall palette start dB, and then waterfall palette length. So right here is the waterfall palette, and whenever you do the start is wherever you're basically adjusting the color palette of the scan. So if you want to lower the colors to a lower noise floor, so the beginning of it is about 90 dB in the black, and then you can increase the length of it too to kind of spread out those colors that are in this bar right here. And that would be, adjusting that would be based on your environment, like I've said many times. But I don't think spur filter, that can help, and many times in very busy areas. And then frequency allocation bands. So this is kind of like a band plan. So what you'll see right here is, so I wasn't sure what the 700, 750 was. If I come up, that is a fixed mobile broadcasting frequency, and it tells me that it is from 698 to 758 megahertz, as well as this frequency right here, these steady frequencies that kind of have a wide bandwidth. Those are broadcasting frequencies. So this is just another tool to add to your list of things. And I hope you guys enjoyed this video basic demonstration of the SDR-BRK and the two softwares that I enjoy using the most. And as always, thank you for watching, and I'll catch you all in the next one.